Hello learners, welcome to an Studio. This is live e-Vidya program for Science and Technology, secondary course of in iOS. I am Neelam Gupta, course coordinator of Environmental Science. Welcome you all in this program. Learners, in our previous program we have discussed lesson number 25, that is heredity. So now we are moving to the next module, that is module 6, natural resources. This module represents different natural resources like abiotic and biotic, air, water, metal, etc. So right now we will discuss air and water during this session. So this is lesson number 26 of your science and technology course. So as we have already know that how much important of all two components, that is air and water, for every living organism's life. So we know that in general we know that air is a mixture of gases and is the one of the main abiotic component of the environment. So air is an extremely important natural resource, as living organisms breathe in air, and in case of humans we breathe about 22,000 times in a day and takes about 16 kg of air into the body during this process. So adult and average adult breathes about 17,000 to 28,000 times per day, inhaling roughly 13 to 16 kg of air depending on activity level. And another major important abiotic component is water. Is also a major component of environment, and water is also essential for all living beings, including humans. Water is the most abundant and renewable natural resource, and it covers about 3/4 of the Earth's surface. Water occurs in nature in a free state as well as in a combined state. So we can say water available in three forms of water has three forms: ice, liquid and snow, vapor. And now we are going to discuss air and water from module 6, natural resources of science in technology level, and this is lesson number 26. So now we go through the concept what we will discuss during this program. We are trying to complete air in this session, and we will take water in another session. So what we are discussing, various component of air and their amount, importance and utility of various air components of air, and we will also talk about air pressure and its use to our life, and various pollutant of air, their consequences and means of control of these pollutant in air. So when we are talking about composition of air, so ancient philosophers consider air as the most vital element. Mayo, a scientist, in 1674 proved that air is not an element but is a mixture of two substances, one of which is active and other is non-active. Lavoisier in 1789 named this active element as oxygen and said that the 1/5 of the total of volume of air, oxygen is present. So non-active element in air is known as nitrogen, and the composition of total volume of air of nitrogen is 4/5. So ratio of oxygen and nitrogen in the air is about 1:4 by volume. So now there is a table which shows different, as we already know, air is a mixture of gases, and there are several gases and some inert gases also, and water vapors too. So composition, when we talk about the composition, nitrogen is 78.03%, oxygen 20.09, argon 0.94, carbon dioxide 0.033, inert gases included neon, helium, krypton, xenon, they are 0.0020. we are not including water in this table because its concentration of water in air varies drastically from location to location. So, a simple activity or question: which of the gas mentioned is important for the following? Photosynthesis. We know photosynthesis is a process by which plants prepare their food, and this process needs oxygen. Carbon dioxide, which we have taken out, and breathing. We take breathing in the presence of oxygen. So you are right, we can say photosynthesis needs carbon dioxide and respiration needs oxygen. And you can also simple activity perform in your home as well as your study center to study the presence of carbon dioxide in air. आप ये खुद से भी कर सकते हैं. इसके लिए ज़रूरी क्या होगा एक्टिविटी करने के लिए? एम है हमारा टू स्टडी द प्रेजेंस ऑफ कार्बन डाइऑक्साइड इन एयर. इसके लिए रिक्वायर्ड है आपके पास एक क्लीन ग्लास हो या टेस्ट ट्यूब अगर है अवेलेबल. अगर से आई सेंटर में तो एक टेस्ट ट्यूब ले सकते हैं. लाइम वाटर यानी चूने का जो पानी होता है, और एक ड्रिंकिंग स्ट्रॉ और ट्यूब. कैंडल एंड मैचेस ये एक ऑप्शनल हो सकता है, अदरवाइज ज़रूरी नहीं है. आपको करना क्या है? व्हाट यू डू, टेक अबाउट 4 ml फ्रेशली प्रिपेयर्ड लाइम वाटर इन ए टेस्ट ट्यूब और ग्लास टम्बलर. एज प्रोसीजर कैसे करेंगे, कैसे हम लाइम वाटर तैयार करते हैं? हाउ वी प्रिपेयर लाइम वाटर. टेक सम लाइम वाटर इन अ ट्रांसपेरेंट ग्लास और टेस्ट ट्यूब. और लाइम वाटर इज अ clear solution of calcium hydroxide in water. Exhaled air test. So blow gently through a straw into the lime water. Observe the change in the solution. So what we observe? Lime water turns milky or cloudy. So this happens because carbon dioxide in your breath reacts with calcium hydroxide to form calcium carbonate, which is insoluble and appears as a white precipitate. When we talk about the optional combustion test, so light a candle and place it under an inverted glass jar. After the flame goes out, pour lime water into the jar. So lime water also turn milky, showing that carbon dioxide is produced during combustion. So how do we conclude? So conclusion is, this experiment demonstrates that carbon dioxide present in air, especially in exhaled breath and combustion gases. So lime water test is a classic method for detecting carbon dioxide. So now we will talk about importance of various components of air. Oxygen, nitrogen, carbon dioxide are directly or indirectly useful for human beings, other animals and plants. Without oxygen and nitrogen, it is not possible for living beings to survive, and water also plays a vital role in our life. So we live on the earth. Earth has its own atmosphere, and we are surrounded by air which contains oxygen. So first we will talk about the oxygen. Oxygen is a vital chemical element. Its symbol is O and atomic number is 8 and atomic weight is 16. That is essential for life, combustion and many industrial processes. When we talk about the properties, it is colorless, odorless gas that make up to 21% of Earth's atmosphere and is crucial for respiration in animals and photosynthesis in plants. So now we talk about importance and utility of oxygen. So as we know, oxygen is a very major component of air, and life cannot possible without oxygen, and it has 3 types of uses. First, general uses, second, medical uses, and third, industrial uses. So first we talk about general uses. We all know oxygen is necessary for respiration, all living beings, including plants too. and it is a supporter of combustion, and therefore materials burn easily in the presence of oxygen. Liquid oxygen called as liquid oxygen is used as oxygen in rockets to burn the fuel. Oxygen from air gets dissolved in water, which keeps the water and aquatic life fresh. Oxygen cylinders are carried by climbers during high altitude climbing, by aviators during high altitude flying, and firemen during firefighting. Rusting of iron takes place in the presence of oxygen and water. When we talk about medical use, so oxygen is given to the patients, those are suffering from asthma or gas poisoning or for artificial respiration in hospitals. A mixture of oxygen and nitrous oxide is used as anesthesia in surgical operations. When we talk about industrial use, so there are so many industries use oxygen. Industrial industry, impurities present in iron are removed by burning in presence of oxygen. For cutting and welding purposes too, oxygen is mixed with hydrogen or acetylene. These mixtures are burned to produce very high temperature and are used for cutting metals and for welding. And oxygen is also used for the manufacture of sulfuric acid from sulfur and nitric acid from ammonia. Everything has a beneficial as well as harmful effects. So oxygen also has harmful effect of first is corrosion. Corrosion means deterioration of metal and by an electrochemical process, and most common example of we want to share, that is rusting of iron, and we all have that experience. So rusting of iron. Oxygen gas and water must be present in for iron to rust. Similarly, articles made by other metals like aluminum and copper also corrode slowly in the presence of oxygen, and oxygen combines with almost all elements to form oxides. So now we move next element, that is nitrogen. Nitrogen is a symbol is N and atomic number is 7. Is also a colorless, odorless, tasteless gas that makes about 70 up to 78% of the Earth atmosphere and is essential for life, agriculture, industries. And nitrogen is the main constituent of protein, and protein is very much important for our growth. A number of amino acids containing nitrogen joining together to form a protein. So protein builds a body. Enzymes which acts as catalyst in biochemical reactions occurring in the body are mostly protein. So now we talk about the uses. There are several uses of nitrogen. Nitrogen subdues the activity of oxygen. If concentration of oxygen is in air is increased, processes like metabolism, combustion and corrosion are speeded up, and that shall have a harmful effect. Hence, due to presence of nitrogen, oxidation of food and combustion of fuel occur at a moderate rate. Compounds of nitrogen are of vital importance to plants, and they help them to manufacture proteins. Animals and humans obtain proteins from plants. Now, next component of the air is carbon dioxide. Carbon dioxide is a composition of two gases, carbon and oxygen. It is a colorless, odorless gas composed of one carbon atom and two oxygen atoms, and also play a very important role in Earth's atmosphere, biology and industry. Percentage of carbon dioxide in air varies from places to places, which two human activities are responsible for increasing carbon dioxide in atmosphere. So when we talk about the main uses of carbon dioxide, so first, photosynthesis. During photosynthesis, plant absorb carbon dioxide and water vapor from atmosphere and convert into carbohydrates or sugars in the presence of chlorophyll and sunlight. Or we can say plants make their food with the help of carbon dioxide, water vapor, chlorophyll and sunlight. Carbon dioxide dissolves in water to form carbonic acid, which reacts with rocks that contain calcium carbonate or magnesium carbonate to form calcium bicarbonate or magnesium bicarbonate salts. These salts give the taste of natural water and also supply calcium and magnesium ions to the plants, which are necessary for their growth. And carbon, it is also used as in food preservation when stored in the atmospheric or carbon dioxide. The grains are prevented from being destroyed by insects. Solid carbon dioxide, which is known as dry ice, is used as refrigerant. Dissolved in water, carbon dioxide is used for in the preparation of soft drinks. The effervescence that comes out when we open a soft drink bottle is carbon dioxide, and carbon dioxide is also used in fire extinguishers. Carbon dioxide also has some harmful effect too. First, it is a greenhouse gas and it traps infrared radiations, which arises the atmospheric temperature and result in global warming. So we have just introduced the word global warming, and this global warming we will discuss more detail in the later program when we talk about the human impact on environment. This is lesson number 30th. So now we will talk about now we are talking about the component of natural resources, component of air and water. So we will just introduce the word global warming. So now we will talk about water vapor. We know that air contains water vapor and its amount in the air is not the same everywhere. So it is a maximum in low latitude and over oceans and is low in the atmosphere over polar regions, and it is also more in summers than in winters. So though water vapors comprises a very small part of the atmosphere, but it plays an important role in heating and cooling of the atmosphere and in a day-to-day change in weather. So in fact, we can say cloud, rain, snow, fog, frost and dew that we experience all result from water vapor present in the atmosphere. But how does water vapor come into the atmosphere? That's question came our mind. So it comes into the atmosphere through a process we call evaporation. So evaporation is a process by which water from any source change into water state, vapor state due to heat, and water evaporates from water bodies due to heat of the sun, forms cloud and then fall as rain upon condensation. So next we will talk about cloud formation. So evaporation, the process is evaporation, rising air, cooling, then condensation, then cloud. So evaporation, the water from oceans, rivers, lake and soil evaporates due to heat from the sun, and plants also release water vapor through evaporation. Then rising air. So warm moist air rising into the atmosphere. As it rises, the air expands and cools. Next, cooling. Then and condensation, we will take both. When the air cools to its dew point, water vapor condenses into tiny droplets. These droplets forms around microscopic particles like dust, pollen or salt, called condensation nuclei, then cloud form. So millions of these droplets cluster together, becoming visible as cloud. The type of cloud depends on latitude, attitude, altitude, sorry, temperature and air movement, then growth and precipitation. If droplets combine and grow heavy enough, they fall as rain, snow or other form of the precipitation. So, this is the process of rain cloud formation. So, condensation of vapor, water vapors in the atmosphere leads to the formation of cloud, and clouds are when moist air rises upward, when dew points means temperature at which the water vapor begins to change into water drops. Is reached, condensation water vapor occurs, resulting in the formation of tiny droplets of water. They cling to the dust particles in the air. These millions of very minute water droplets or tiny ice crystals almost hang in the air rather than fall. Then they are blown by as clouds by the wind. So, when we talk about different types of cloud, so you can observe different types of clouds if you watch the sky, cloud sky carefully. So, clouds are of different types according to their shapes and height. High cloud, mid-level cloud, low clouds and vertical clouds. So, high clouds include ice crystal based, thin and wispy. Mid-level cloud, water droplets often layered. Low cloud, thick grey fog-like sheets, and vertical cloud towering formed by strong convection can bring storms. So, we feel or we examine or we observe different types of clouds. So, next we will talk about the rain. As we say, when clouds rise up, they are cooled. When blown into cooler region to the atmosphere, then small droplets of water in them become still cooler and they come closer to each other. So, number of small droplets combine to form a big drop of water, and these drops are so big that they can no longer float in the air and they fall down on the earth as a rain. As they fall, they pick up and more small drops of water in their way down. So, there are some interesting facts. So, we will discuss. The falling of big drops of water from a cloud is known as rain, and the process is called precipitation. An instrument by which we measure rainfall is known as rain gauge, and rainfall is measured in centimeter. So, maximum rainfall occurs in the countries near equator regions and Southeast Asia. In these regions, annual rainfall is 200 centimeter or even more. The lowest rainfall occurs in tundra, Central Asia and hot deserts, where it is less than 25 centimeter. The medium rainfall occurs in West European countries, Taiga regions and China. So, now we take a short break. After which we will continue this discussion. we have talked about, before we taking break, we have talked air is a mixture, and we have also discussed about various components of air and their uses, and we have talked about cloud formation and rain. Now we are moving ahead, or we will discuss about what is relative humidity. So first, what is humidity? So presence of water vapor or moisture in the atmosphere is known as humidity, and it is related. It is humidity of air is related to its temperature. So during summer, we have experienced days when both temperature and humidity are high. So what is relative humidity? Is the ratio of the mass of water vapor actually present in a certain volume of air at room temperature to the mass of water vapor required to saturate the same volume of air at that temperature. So while mentioning the relative humidity, it is necessary to mention the temperature too. And the instrument used for to measure relative humidity is known as hygrometer. So we know that, or we have already discussed, air is a mixture of different gases, and molecules of these gases have weight due to gravity. So now we talk about air and its pressure. So anything that have weight pushes and presses against other objects. Envelope of air that surround the earth or atmosphere exert a force which acts downward on the surface of the earth. So force of air column acting per unit area of a surface result as a pressure exerted by the atmosphere, and this is atmospheric pressure, and is measured is about atmospheric pressure is about 1 kg centimeter square or 10 ton meter square. So we can take if we want to show air exert pressure, so we can take an activity. So take any empty bottle, mineral water, water bottle or any water, and add some hot water. So what do we do? We take empty bottle of mineral water or any water bottle, plastic bottle, take some hot water in it or tightly screw it gap in order to make it airtight, and pour cold water on the bottom. So what do you observe? So you will find that bottle collapses and becomes misshapen when the water vapor inside cools and condenses water into water. So as you seen in the figure, you will find the same result if you apply this. Reason questioning or answer reason is this: why is it came our mind? Why is it so? So when hot water is taken into the empty bottle, so air present in it become hot and expand. Also some air comes out of it. On cooling, the air inside the closed bottle contracts. This creates a partial vacuum inside the bottle. So atmospheric pressure acted from outside presses the bottle and causes the bottle to collapse, and this shows that air exerts pressure. And there are several examples in day-to-day life. Atmosphere, as we know, atmospheric pressure plays an important role in the working of many things, like working of a straw, working of a syringe or ink dropper, working of a water pump, and many more other examples. So now we move to the variations of air pressure with height. We know atoms and molecules of the gases in the atmosphere, like those of other matters, are subject to Earth's gravitational force. As a consequence, the atmosphere is much denser near the surface of the Earth than at higher altitude, and the density of air decreases very rapidly with increasing distance from Earth. So, therefore, we can say atmospheric pressure also decreases with altitude, often at higher altitude. People experience their nose bleeding. That is why? Because blood pressure of the body is much more than the pressure outside. And air pressure is measured by the instrument which is known as barometer. So, we are talking so much about atmosphere. So, now we will talk about the different layers of the atmosphere. The region of air around Earth is known as or called atmosphere, and it protects us and all living organisms from harmful radiations from of the sun like UV rays. So, we can divide atmosphere into different layers according to their temperature, pressure, variations and compositions. So, there are several layers. Main layers की बात करें तो from the surface of the earth upward are troposphere, stratospheres, mesospheres and thermosphere. We will talk little bit detail about troposphere. Altitude ranges 0.8 to 15 kilometer. Its key feature of the troposphere is closer to earth, where weather occurs contains most of the atmospheric mass. Second layer is stratosphere. Altitude ranges approximately 15 to 30 kilometers, 50 to 50 kilometers. It contains the ozone layer, which absorbs harmful UV radiations. Planes fly there. Planes often fly there. Next layer is mesosphere. Its altitude ranges approximately 50 kilometer to 85 kilometers. Coldest layer, meteors burns up here due to friction with air molecules. Next layer is thermosphere. Altitude ranges 85 to 600 kilometers. It's very thin layer. Temperature rises sharply. It occurs here home to the International Space Station. So, there are 4 layers. So, most active region of the atmosphere we know troposphere, layer of the atmosphere, which contains 18% of the total mass of the air and practically all the atmosphere's water vapor, and it is the thinnest layer of atmosphere, and all the dramatic events of weather occurs here. So, you must have observed the black spot deposition on the plant growing in areas with heavy vehicular traffic. Have you wondered why? Answer may be it is because of pollutants which are present in the air, or we can say simply due to air pollution. So, these air pollutants are one of the cause of air pollution. So, air pollution is the introduction of harmful chemicals, biological waste and particulate matter into the atmosphere. Pollution has harmful effect on humans as well as on the other living beings and non-living beings too. So, pollutant may be classified into 2 main categories, that is primary pollutant and secondary pollutant. What are primary pollutants? Which are directly emitted into the atmosphere, like carbon monoxide from exhaust of a motor vehicle. Secondary pollutants which are not emitted directly into the atmosphere but are formed in air when primary pollutants interact. So, now we talk about major pollutants, include carbon monoxide, carbon dioxide. So, carbon monoxide is produced by incomplete combustion of fuels like petrol, natural gas, coal or wood. And like other gases, it is also colorless and odorless gas, but very poisonous in nature. Carbon dioxide is produced by complete combustion of fuels in motor vehicles and various industries. It is also colorless, odorless and non-toxic gas. Person dies in the atmosphere of carbon dioxide due to lack of oxygen and not due to its toxic nature. Sulfur dioxide or sulfur oxides, mainly sulfur dioxide, are produced by combustion of coal and petroleum and also produced in volcanic eruption, during volcanic eruption, and it is also produced in various industrial processes. Oxidation of sulfur dioxide to sulfur trioxide results in formation of sulfuric acid, which causes acid rain. Oxides of nitrogen, especially nitrogen trioxide, is a reddish brown gas with pungent smell, and it catalyzes the oxidation of sulfur dioxide to sulfur trioxide and indirectly causes acid rain. Volatile organic compounds include methane, benzene, toluene and xylene. While methane is a major greenhouse gas, others are suspected to be carcinogenous, means cancer causing or cancer inducing. Particulate matters consist of tiny particles of solid or liquid suspended in air. These are also called as SPM or suspended particulate matter. Major sources of these include volcanic eruption, dust storm and burning of fuels, and these can cause heart and lung diseases and breathing disorders. There is another gases known as CFCs. Chlorofluorocarbons are used as refrigerant in air conditioners and refrigerators and are harmful to the ozone layer, which protects us from harmful UV rays. So again, when we talk about ozone hole or ozone layer, so we will discuss in detail when we talk about human impact of environment. So now we talk about major secondary pollutants. Include photochemical smoke in the form of smoke and fog formed by the action of ultraviolet light from the sun on particulate matter, or formed due to burning of coal and petrol in atmosphere containing sulfur dioxide, and it prevents dissipation of pollutants and causes breathing disorder. This will also talk about smoke when we discuss about human impact. So ground level ozone is formed from oxides of nitrogen and volatile organic compounds, and it is a main constituent of smoke. Normally ozone layers occur in the stratosphere and prevents ultraviolet rays from reaching Earth's surface, and at ground level when inhaled it is harmful for health of humans and animals. So now we are concluding few points in the form of what you have learnt this session. We have discussed air only, and what we have already said. We will discuss water in another session. So now we move what we have discussed during this session. Major component of air are nitrogen and oxygen. Air is a mixture of gases. Air also contains argon, carbon dioxide and some traces gases like neon, helium, krypton and xenon. It also contains water vapor. The weight of air volume acting per unit area results in a pressure exerted by atmosphere called atmospheric pressure. Atmospheric pressure plays an important role in our everyday life, in the working of common devices like ink dropper, straw and water pump. State of atmosphere in relation to the amount of water vapor present is known as humidity. We have talked about air, its component, use of gases and atmospheric pressure, relative humidity. So now we are closing this session right now. We will come again to meet you in a new program of science and technology. Till then, goodbye and thank you.